order functions and operations on callable objects. The Functools module is for higher order functions, functions that act on or return other functions. In general, any callable object can be treated as a function for the purposes of this module. Functools module defines the following functions: at the rate functools.cache, user function, simple, lightweight, unbounded function cache, sometimes called memoize, returns the same as LRU underscore cache, maximize max size is equal to none, creating a thin wrapper around a dictionary lookup for the function arguments. Because it never needs to evict old values, this is smaller and faster than LRU cache with a size limit. For example, cache d factorial return n into factorial n minus 1 if n else 1, factorial 10 3 6 2 8 8 0 0, no previously case result, make 11 recursive calls, factorial 5 just look up cache value result 120, factorial 12 makes 2 new recursive calls, the other 10 are cached. The cache is thread safe so that the wrapped function can be used in multiple threads. This means that the underlying data structure will remain coherent during concurrent updates. It is possible for the wrapped function to be called more than once if another thread makes an additional call before the initial call has been completed and cached. At the rate functels.cached property func transform a method of a class into a property whose value is computed once and then cached as a normal attribute for the life of the instance, similar to property with the addition of caching, useful for expensive computed properties of instances that are otherwise effectively immutable. Class dataset diff init self sequence of numbers self.data tuple sequence of numbers, cached property diff standard deviation self return statistics dot standard deviation uh, self.data. The mechanics of cached property are somewhat different from property. A regular property blocks attribute writes unless a setter is defined. In contrast, a cached property allows writes. The cached property decorator only runs on lookups and only when an attribute of the same name doesn't exist. When it does run, the cached property writes to the attribute with the same name. Subsequently, attribute reads and writes take precedence over the cached property method and it works like a normal attribute. The cached value can be cleared by deleting the attribute. This allows the cached property method to run again. The cached property does not prevent a possible race condition in multi-threaded usage. The getter function could run more than once on the same instance with the latest run setting the cached value. If the cached property is idempo, idempotent or otherwise not harmful to run more than once on an instance, this is fine. If synchronization is needed, implement the necessary locking inside the decorated getter function or around the cached property access. Note: this decorator interferes with the operation of PEP412 key sharing dictionaries. This means that instance dictionaries can take more space than usual. Also, this decorator requires that the dictionary attribute on each instance be a mutable mapping. This means it will not work with some types such as meta classes, since the dictionary attribute on type instances are read-only proxies for the class namespace, and those that specify slots without including dictionary as one of the defined slots. As such classes don't provide a dictionary attribute at all. If a mutable mapping is not available or if space efficient key sharing is desired, an efficient similar to cache property can also be achieved by stacking property on top of LRU cache. See how do I cache method calls for more details on how this differs from the cached property. Functool does compare to key function. Transform an old style comparison function to a key function used with tools that accept the key functions such as sorted, mean, max heap queue dot and largest heap queue dot and smallest itr tools dot group by. This function is primarily used as a transition tool for programs being converted from Python 2, which supported the use of comparison functions. A comparison function is any callable that accepts two arguments, compares them, and returns a negative number for less than 0 for equality, or a positive number for greater than. A key function is a callable that accepts one argument and returns another value to be used as the sort key. Example: sorted iterable key is equal to compare to key local dot str call local aware sort order. For sorting examples in a brief sorting tutorial, see sorting out. Functools dot functools.lru cache user function. Functool.lru cache max size 128 typed is equal to false. Decorator to wrap a function with a memoizing callable that saves up to maximize most recent call. It can save time when an expensive or IO bound function is periodically called with the same argument. The cache is thread safe so that the wrapped function can be used in multiple threads. This means that the underlying data structure will remain coherent during concurrent updates. It is possible for the wrapped function to be called more than once if another thread makes an additional call before the initial call has been completed and cached. Since a dictionary is used to cache results, the positional and keyword arguments to the function must be hashable. Distinct argument patterns may be considered to be distinct calls with separate cache entries. For example, f a is equal to 1, b is equal to 2, and f b is equal to 2 and a is equal to 1 differ in their keyword argument order and may have two separate cache entries. The user function is specified, it must be a callable. This allows the LRU cache decorator to be applied directly to a user function, leaving the max size at its default value of 128. At the rate LRU cache diff count vowels sentence returns some sentence dot count vowel for vowel in this one. If max size is set to none, the LRU feature is disabled and the cache can grow without bound. If typed is set to true, function arguments of different types will be cached separately. If typed is false, the implementation will usually regard them as equivalent calls and only cache a single result. Some types such as string and integer may be cached separately even when typed is false. Note: type is specificity applies only to the function's immediate arguments rather than their contents. The scalar arguments decimal 42 and fraction 42 are treated as distinct calls with distinct results. In contrast, the tuple arguments answer, comma, decimal 42, answer, comma, fraction 42 are treated as equivalent. The wrapped function is instrumented with a cache parameter function that returns a new dict showing the values of max size and type. This is for information purposes only. Mutating the values has no effect. To help measure the effectiveness of the cache and tune the max size parameter, the wrapped function is instrumented with a cache info function that returns a named tuple showing hits, misses, max size, and curve size. The decorator also provides a cache clear function for clearing or invalidating the cache. The original underlying function is accessible through the wrapped attribute. This is useful for introspection, for bypassing the cache, and for rewrapping the function with a different cache. The cache keeps references to the arguments and return values until they age out of the cache or until the cache is clear. If a method is cached, the self instance argument is included in the cache. See how do I cache method calls. An LRU, least recently used cache, works best when the most recent calls are the best predictors of upcoming calls. For example, the most popular articles on a news server tend to change each day. The cache size limit assures that the cache does not grow without bound on long running processes such as web servers. In general, the LRU cache should only be used when you want to reuse previously computed values. Accordingly, it doesn't make sense to cache functions with side effects, functions that need to Create distinct mutable objects on each call, such as generators and async functions, or impure functions such as time and random. Example of LRU cache for static web content. LRU cache max size 32, get pep, retrieve text of a Python enhancement proposal resource. This try with try with try with url lib.request.url open resource as return as.read accept url lib.error.http error return not found for n in 8 29308. This pep is equal to get pep n print n length n. Example of efficient computing Fibonacci numbers using a cache to implement a dynamic programming technique. LRU cache max size is equal to none def fib n. If n less than 2, return n. Return fib n minus 1 plus fib n minus 2. Fib n for n in range 16. Fib.cache info. Hits 28, misses 16, max size none, current size 16. Functools.total ordering. Given a class defining one or more rich comparison ordering methods, this class decorator supplies the rest. This simplifies the effort involved in specifying all of the possible rich comparison operations. The class must define one of the less than or equal to greater than or greater than equal to. In addition, the class should supply an equal method. For example, total ordering student is valid operand other has attribute other last name and has attribute other first name equals self dot other not self dot is valid operand other return not implemented return self dot last instance dot lower self dot first instance dot lower equal to other dot last instance last name dot lower self dot first name dot lower less than self dot other comma other if not self is valid operand other return not implemented return self dot last name dot lower comma self dot first name dot lower less than other dot last name dot lower other dot. While this decorator makes it easy to create well behaved totally ordered types, it does come at a cost of slower execution and more complex stack traces for the derived comparison method. If performance benchmarking indicates this is a bottleneck for a given application, implementing all six rich comparison methods instead is likely to provide an easy speed booster. This decorator makes no attempt to override methods that have been declared in the class or its superclass, meaning that if a superclass defines a comparison operator, total ordering will not implement it again, even if the original method is abstract. Functools.partial func slash pointer args pointer keyword args return a new partial object which when called will behave like func called with positional arguments arg and keyword arguments keyword args. If more arguments are supplied to the call, they are appended to args. If additional keyword arguments are supplied, they extend and override keywords, roughly equivalent to partial func this. The partial is used for partial function application which freezes some portion of a function's argument and or keywords resulting in a new object with a simplified signature. For example, partial can be used to create a callable that behaves like the integer base argument defaults to 2. From functools import partial base 2 partial integer base 2 base 2 dot doc convert base 2 string to an integer base 2 10011. Class functools dot partial method func ars keyword ars return a new partial method descriptor which behaves like partial except that it is designed to be used as a method definition rather than being directly callable. Funcs must be descriptor or a callable. Objects which are both like normal functions are handled as descriptor. When func is a descriptor such as a normal Python function, class method, static method, abstract method, or another instance of partial method, calls to get are delegated to the underlying descriptor and an appropriate partial object returned as a result. When func is a non-descriptor callable, an appropriate bound method is created dynamically. This behaves like a normal Python function when used as a method. The self argument will be inserted as the first positional argument even before the R's and keywords applies to the partial method constructor. Example class cell div init self dot alive false property div alive self return self dot alive div set state self dot alive is equal to bool state set alive is equal to partial method set state true set date partial method set state false c is equal to cell c dot alive c dot set alive c dot alive functools.reduce function comma iterable comma initializer apply function of two arguments cumulatively to the items of iterable from left to right so as to reduce the iterable to a single value. For example, reduce lambda x y x plus y 1 2 3 4 5 calculates 1 plus 2 plus 3 plus 4 plus 5. The left argument x is the accumulated value and the right argument y is the updated value from the iterable. If the optional initializer is present, it is placed before the items of the iterable in the calculation and serves as a default when the iterable is empty. If initializer is not given and iterable contains only one item, the first item is returned. Roughly equivalent to reduce function iterable initializer is equal to none. It is equal to iterable. If initializer is none, value is equal to next else value is equal to initializer. For element in a value is equal to function value element return value at the rate functools dot single dispatch transform a function into a single dispatch generic function. To define a generic function, decorate it with the single dispatch decorator. When defining function using single dispatch, note that the dispatch happens on the type of the first argument. From functools import single dispatch func arg verbose false. If verbose print let me just say and is equal to this print args. To add overloaded implementations to the function, use the register attribute of the generic function, which can be used as a decorator. For functions enumerated with types, the decorator will infer the type of the first argument automatically. Func register div arg was print strength in numbers yeah print func register args list verbose false if verbose enumerated list I in element in enumerate args types dot union type and typing dot union can also be used at the rate func dot register div underscore arg integer or float verbose false if verbose from typing import union at the rate func register arg is equal to union list set verbose false verbose. For code which doesn't use type annotations, the appropriate type argument can be passed explicitly to the decorator itself. Func.register complex div underscore arg verbose is equal to false. To enable registering lambdas and pre-existing functions, the register attribute can also be used in a functional form. If nothing arg verbose false print fun.register type is equal to none nothing. The register attribute returns the undecorated function. This enables decorator stacking pickling and the creation of unit tests for each variant independently. At the rate func register float register decimal func number arg verbose is equal to false if verbose half of your number and print half of the number func number is 1 false. When called, the generic function dispatches on the type of the first argument. Func hello world fun test verbose true. Let me just say that fun 42 verbose true strength in numbers yet 42. Fun spam x spam verbose true. Red list this fun none nothing fun 1.2 this. Where there is no registered implementation for a specific type, its method resolution order is used to find a more generic implementation. The original function decorated with single dis, single dispatch is registered for the base object type, which means it is used if no better implementation is found. If an implementation is registered to an abstract base class, virtual subclasses of the base class will be dispatched to that implementation. From collections.abc import mapping fun register diff underscore arg mapping verbose is equal to false. If verbose print keys and values for key value in arg.items print key value func ab. To check which implementation the generic function will choose for a given type, use the dispatch attribute fun.dispatch float fun.dispatch dict. To access all registered implementation, use the read-only registry attribute func.registry.keys fun.registry float fun.registry object. Class functools.single dispatched method funcs transform a method into single dispatch generic function. To define a generic method, decorate it with the single dispatch method decorator. When defining a function using single dispatch method, note that the dispatch happens on the type of the first non-cell and non-CLS argument. Class negator single dispatch method def negate self arg not implemented error. Negate register underscore self arg integer return minus r. Negate dot register self dot bool not arg. Single dispatch methods supports nesting with other decorators such as class method. Note that to allow a dispatcher.register single dispatch method must be the outermost decorator. Here is the negator class with the neg func methods bound to the class rather than an instance of the class. Class negator single dispatch method class method neg not implemented class method class. The same pattern can be used for other similar decorators, static method, abstract method, and others. Functools update wrapper. Wrapper wrapped assigned is equal to wrapper assignments. Update is equal to wrapper updates. Update a wrapper function to look like the wrapped function. The optional arguments are tuples to specify which attributes of the original function are assigned directly to the matching attributes on the wrapper function and which attributes of the wrapper function are updated with the corresponding attributes from the original function. The default values for these arguments are the module level constants wrapper assignments, which assigns to the wrapper functions module name, call name, annotations, and doc, the implementation string. The wrapper updates, which updates the wrapper functions dict instance dictionary. To allow access to the original functions for introspection and other purposes, bypassing a caching decorator such as LRU cache, this function automatically adds a wrapped attribute to the wrapper that refers to the function being wrapped. The main intended use of for this function is in decorator functions which wrap the decorated function and return the wrapper. If the wrapper function is not updated, the metadata of the returned function will reflect the wrapper definition rather than the original function definition, which is typically less than useful. Update wrapper may be used with callables other than functions. Any attributes named in assigned and updated that are missing from the object being wrapped are ignored. This function will not attempt to set them on the wrapper function. Attribute error is still raised if the wrapper function itself is missing any attributes named in update. Functools.wraps wrapped assigned is equal to wrapper assignment updated is equal to wrapper updates. This is a convenience function for invoking updated wrapper as a function decorator when defining a wrapper function. It is equivalent to partial updated wrapper wrapped is equal to wrapped assigned is equal to assigned updated is equal to updated. For example, from functools import wraps diff my decorator f wraps f diff wrapper args keyword args calling decorated function return f args keyword args my decorator example doc string called example call decorated function call example dot name example. Without the use of this decorator factory, the name of the example function would have been wrapper. and the doc string of the original example would have been lost. Partial objects are callable objects created by partial. They have three read-only attributes. Partial.func, a callable object or function, calls to the partial object will be forwarded to func with new arguments and keywords. Partial.args, the leftmost positional argument that will be prepended to the positional arguments provided a partial object call. Partial.keywords, the keyword arguments that will be supplied when the partial object is called. Partial objects are like function objects in that they are callable, weak referenceable, and can have attributes. There are some important differences. For instance, the name and doc attributes are not created automatically. Also, partial objects defined in classes behave like static methods and do not transform into bound methods during instance attribute lookup. Thank you.